Alright, here's another one of those problems that's sort of like uh, come up with a counterexample somehow that proves your point. So I don't really like these types of problems because I don't necessarily see or I don't always see how would you come up with this counterexample, and it's not necessarily enlightening. Um, Maybe it'd be cool if whenever, say if someone were to present this counterexample, um, either they're going to find the counterexample from someone else, or if they came up with the counterexample themselves, they should give some sort of idea of what led them to think of this counterexample. Um, and if it just happens that they stumbled upon it, then I don't. That's annoying as well. That's not very enlightening. So here's the. I think I sort of have an idea of how you would come up with this, but anyways, you take m to be z mod 4z, and then assume for contradiction we can make m a Q module with action phi. Then phi of say 1/2, and then the conjugacy class of 1, conjugacy class, equivalence class, whatever. This must be an element of M. So say phi of 1/2, 1 is A. Then 1 bar is equal to, well, it's phi of 1, comma 1. Because 1 will fix everything, and then we write 1 is 1/2 plus 1/2. And of course, because this is a module, we can bring this plus out, and this becomes A plus A. Now, in M, 0 plus 0 equals 0. Let's just go through and see what happens. So 1 equals 2. 2 plus 2 equals 0. And 3 plus 3 is 2. So A cannot be an M because there is no element in M such that if you add it to itself, it becomes 1. So hence, this is a contradiction. So I guess in some sense you should expect to look for somewhere here, okay, you're gonna want to use the properties of the modules and how they work. So maybe you'd have to do something like this, like bringing this plus out, and 1/2 is typically a thing, because finite abelian groups tend to be very discrete, I guess, and so but the rational numbers are sort of discrete in that they're, well, but not really, they're dense in R, which isn't really something that I guess comes into play here because we're not in this problem. We're not talking about R at all. But you should think that maybe you have to deal with fractions, like fractions between 0 and 1, to maybe come up with a counterexample. So I guess in that sense, that might steer you in this direction of, oh, maybe we have to think of something where you have you add something to itself and it gives you 1 or something like that. But other than that, I don't really know how you would come up with this example. I don't really find this very enlightening. I don't feel like this helps me in my understanding of modules. But I mean, I guess that's just my opinion. So yeah, in any case, regardless of how you feel about this problem, this is a proof that M cannot be made into a left Q module if M is a finite abelian group, which is non-zero.